In this video, we will find the derivative of the natural logarithm of x using the definition of the derivative, which we have written right here. Before we begin, let's define the exponential function as the sum from n is equal to 0 up to infinity of x raised to the nth power divided by n factorial. So let's begin. We have the derivative of f with respect to x equal to the limit as h approaches 0 of the natural logarithm of x plus h minus the natural logarithm of x divided by h. Now remember, if we have something of this form, we can rewrite it like this, and also if we have something of this form, we can rewrite it as this. So let's just go ahead and do that. We have the limit as h approaches 0, the natural logarithm of x plus h divided by x So we've just used these rules right here. Now we can simplify this further. We have the limit as h approaches 0 of the natural logarithm of 1 plus h over x, all raised to 1 over h. At this point we want to make the following substitution. Let t be equal to h over x, and as h goes to 0, t go to 0 also. So we're going to have the limit as t approaches 0 of the natural logarithm of 1 plus t raised to 1 over, we have tx equal to h, so it's tx right here. Now what we can do here is move the limit to inside the logarithm. And we can raise this to the 1 over x power. And we can actually raise the whole limit to the 1 over x power. And we can actually use the rule that we used above and bring the power down to the front right here. So we have 1 over x multiplied by the natural logarithm of the limit as t goes to 0 of 1 plus t raised to 1 over t. Now the only thing left to do is evaluate the limit. First, let's expand 1 plus t raised to 1 over t using the binomial formula. This gives us 1 plus 1 over t plus 1 over t multiplied by 1 over t minus 1 divided by 2 factorial multiplied by t squared plus 1 over t multiplied by 1 over t minus 1 multiplied by 1 over t minus 2 divided by 3 factorial multiplied by t cubed, and it would just continue in that fashion. We can simplify this as 1 plus, there should be a t here, so that's just 1 here, plus 1 times 1 minus t divided by 2 factorial plus 1 multiplied by 1 minus t multiplied by 1 minus 2t divided by 3 factorial. We can now rewrite our expression using what we have here. So let's go ahead and do that. We have 1 over x multiplied by the natural logarithm of the limit as t approaches 0 of 1 plus 1 plus everything up here. So 1 times 1 minus t divided by 2 factorial plus 1 times 1 minus t times 1 minus 2 times t divided by 3 factorial. Now let's just go ahead and let t be equal to 0. So we have 1 over x multiplied by the natural logarithm of 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial Now remember before we defined E as the following. This is just 1 plus x squared over 2 factorial. Now notice that we have a 1 here and we have a 1 here. So if we were to just write e to the first power, we would have 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial. So what that tells us is that this is equal to e raised to the first power. And we've just figured that out by using the definition here. Finally, we have 1 over x multiplied by the natural logarithm of e raised to the first power, and these two cancel each other out, and we're just left with 1 over x. If you found this content useful, make sure to like, subscribe and follow for more. If you have any questions at all, make sure to leave them in the comment section below. I hope you have a great day. Thank you very much for watching.